For more problems and videos like this for linear algebra, you can take a look at Sarai Studies. Link is in the description box below.
The first question was, what are these conditions good for if it's really unrealistic to use them to prove that a subset is a subspace? Well, they're good for the opposite. They're good to prove that a subset is not a subspace, because it's so easy to just take two vectors, and if you take the sum of those two vectors and it's not on that subset, then you can automatically say, okay, it's not a subspace because it fails to meet one of the conditions of a vector space. So if it's not a vector space, then that subset cannot be a subspace. It just stays as a subset of V. So let's do an example. Determine whether the following subset of R of n is your vector space, and they're giving us a subset. So I like to think of my vector space as a box. A subset is something inside that box. We want to know if this thing inside this vector space is a subspace, and if it is a subspace, find a generating set for it, and we'll talk about what that means. So this is a subset that they're giving you. They're telling us that the vector space is R2. It's two-dimensional, aka the coordinate plane. And then they have this condition. They're saying that this subset is this. This is an equation of a circle. So we have this dimensional space R2, which is just a vector space. We can call it big V. So a subset is just definition, something inside that vector space. Then you would ask yourself, what is a subspace? A subspace is just a subset, something inside this vector space that also satisfies the conditions of a vector space. So if they're asking you, is H a subspace, you're really asking, is H a vector space also? Because if it is, then we can say that it's a subspace of V. And then realistically, you know that you can't use these conditions to prove that H is a subspace of V, because you can't possibly have the time to take all vectors, all points on this circle on H, add them together and make sure that their sum is still on that circle. And same thing for this condition right here. So the strategy with these questions is to use these conditions to check if it's not a subspace of V in the first place. So if we go with condition 1, we know that condition 1 is that the 0 vector is an element of, so it's in H. Then you ask yourself, is the 0 vector in H? 0 vector is right here. That's not on this circle. And so because the 0 vector is not on this circle, then therefore it fails this condition. 0 is not on the circle. 0 is not on H. 0 is not on the subset, however many ways you want to say it. Because it fails this condition, H is not a vector space. And because a subspace is just a subset, it's H that's a vector space, and we already know it's not, then it's just simply a subset. So H is not a subspace. In other words, it's not a vector space within another vector space. It's simply just a subset, simply just something inside the vector space. So that is a strategy. When you're asked if a subset is a subspace, you first want to use these conditions and see if you can prove that it's not, because it's so easy, this first one especially. If 0 is not on that subset or on that graph, whatever, then we already know it's not a subspace because it doesn't meet this condition of a vector space. Now, what if I told you that you couldn't use this condition to prove that H is not a vector space, hence proving that H is not a subspace of V? Then you can use maybe this condition. You can take any number and any vector, any point on H, multiply them, and if you get something that's outside of H, that's not a point on H, then you can prove that it's not a vector space. So let's say I want to do 2, it could be any number, then I would have to pick a point on H, and we know the basic points of a unit circle in vector form, 1, 0. So if I do 2 times 1, 0, that's going to just give me 2, 2 times 0 is 0, and if I go ahead and plot this vector, 2 zeros right here, then you ask yourself, is that on H? It's not on H. And so I took a vector A, and its result's supposed to be on H. It's supposed to be an element of H, but it's not. 2, 0 is not on H. It's actually outside of it. It's not on the circle. It's not on the subset. Therefore, I prove that H is not a vector space because it fails this condition as well. And so because it's not a vector space, then it's just a subset. It's not a subspace. Now, what happens when something is a subspace? How do you prove that it is?